Let's look at using a mathematical formula when doing calorimetry problems, and I want to offer some suggestions. Here's one way to express the formula. Let's dissect it. Q is the amount of heat that's transferred. It can be joules, kilojoules, calories, kilocalories. S is the specific heat capacity for a substance or a solution. We're going to take it as a constant. I don't mean exact, but we'll take it as independent of temperature. It's not really, but the study of that is more suited for a physical chemistry class. I have the word capacity in parentheses because common usage over the years has been to remove the word capacity and to just say specific heat. I go back and forth. I say both. I think the word capacity, if you leave it in there, it might help you remember to keep it separate from heat. Q and S are not the same things. M is the mass of the solution or the substance. And then we have the change in temperature. It's not the final, it's not the initial, it's the change in temperature. A challenge from your point of view when studying is if you orient all your studying of this around the formula, what happens if in the middle of an exam you have a core dump and you can't remember the formula? Let me present the formula in an alternate format. It's still a mathematical formula, but I think it explains things a little better. I'm going to go one more step, though, and suggest you don't even need either formula. Two ways to approach these problems. One is you could be asked to calculate the specific heat. The other way is you are given the specific heat, or you have to look it up, and then you're asked to calculate either heat or mass or something to do with the temperatures changing. Therefore, memorize the units for specific heat: joules per gram degrees Celsius, or whatever heat units you're using. And then focus on that. For example, if you are asked to calculate the heat transferred, you know when you're done, you have to have heat units in the numerator, not the denominator. Therefore, you could start with the value of specific heat, like this, with the number that's associated with it, and then do your unit analysis. If instead you're being asked to calculate the mass, you could rearrange this formula. But when you rearrange this formula, then you have to take the specific heat capacity, which has a set of combination units in it, and put it in the denominator, and that presents its own problems for unit analysis. So instead, take the value of the specific heat and reciprocate it. Because you know you want mass units when you're done, make sure the mass units are in the numerator when you're done. Then do your unit analysis. Now let's look at delta T. What if you were asked to calculate not the change in temperature, but either the final or initial temperature? Let's say we were taking a sample of a metal that's hot and putting it in cold water, and we want to calculate the final temperature of that piece of metal. Let's do some formula rearranging. First, I'll isolate TF minus TI, because that's delta T, final minus initial temperature. Now, since the problem says what's the final temperature, I'll rearrange that. Do you see the implication in that bottom formula? Think about how I set the problem up. I said that it's a hot piece of metal being put into cold water. Therefore, the temperature's going down. But this formula appears to suggest that the final temperature is greater than the initial temperature. Let's look at a picture. There's my cube of metal in my water sample. It's cooling down. Do you see what I did wrong? It's when I set it up. That's an exothermic process with respect to the cube. Therefore, what I did was, look at the top formula, I forgot to put the sign in. Exothermic gets a negative sign because it's heat being transferred out of the system. So now I need to fix the second formula. Now I need to fix the bottom formula. And now I'll do a rearrangement. And now that formula on the bottom, that better shows that the final temperature is lower than the initial temperature. Let me give you a suggestion for problems in which you're calculating final or initial temperature. Don't directly solve for final or initial temperature. If you do, you have to worry about the sign for heat transfer. Instead, first calculate the change in temperature. Then go back, read the problem, and it'll be obvious in the way the problem is set up as to whether the final temperature is lower or greater than the initial temperature, and then that'll let you calculate either the initial or final temperature. So my suggestion is a problem like that, turn it into 2 steps.